This conference will now be recorded.
Good morning to everyone. So in the last session we started with the operators, like Verilog operators. So we'll just 5 or 10 minutes we'll recap and then we'll start with the other operators today. Okay. So what are the Verilog operators we talked about? What are the Verilog operators? Verilog operators. So Verilog operators are broadly classified into many classes, correct? First one is what? Arithmetic operator. So what are the arithmetic operator symbols? Addition, correct? Subtraction, multiplication, division, modulus, exponential operation. Power operation, correct? So these are the operators. First arithmetic operator. What is second operator we talked about? Logical operator. So what are the logical operator symbols are? Logical AND operator, correct? Logical OR operator, logical NOT operator. So after this we talked about relational operator. What are the relational operators? Greater than, less than, greater than or equal to, less than or equal. Correct. These are the relational operators. And after this we'll talk about what? Equality operators. So what are the equality operators? Equal to, and then not equal to. This is the equality operator. And then we have the Verilog also supports the special equality, that is nothing but case equality operators. What is the case equality operator is? Equal to, correct? Then not equal to. Did you understand? So after this, what operator we talked about? Bitwise operators, correct? Bitwise operator. So what are the bitwise operator is? Bitwise not operator, middle symbol. Bitwise AND operator, bitwise OR operator, bitwise NAND operator, bitwise NOR operator, bitwise XOR operator, and bitwise XOR operator. This also you can write what? Like this symbol. Correct? Both are same. Then after this, what we talked about? Reduction bitwise operator. Correct? Reduction bitwise operator. What are the reduction bitwise operators are? And, correct? Then and OR. So these both are same. Correct? And OR. Then so like NAND, NOR, correct? XOR, XNOR. So there is a difference between reduction operator and bitwise operator. So this logical operator and bitwise reduction operator will yields a result of how many bits? One bit. Where this equality operator yields a multi-bit result. Correct? So we spoke about that. And after this, what operator we started with? Shift operators, right? Shift operator. What are the shift operators we have? Shift right means what? 2 greater than symbol. Shift left means what? 2 greater than symbol. So I am leaving you as an assignment. You can see what is this operator. This is nothing but what? 3 greater than symbol. 3 greater than and 3 less than. The logic is same. These also do the right shift operation. These also do the left shift operation. There is a small logic here. You see what is this 3 greater than symbol right shift operation and 3 greater than symbol left shift operation. If you use this will be working as a arithmetic right shift and the arithmetic left shift. You see that what is meant by arithmetic right shift and the arithmetic left shift. And also we understand that shift operator is basically using for doing some operations. Correct? What operations is? Shift and OR operation for the multiplication and some other data manipulation operation. Correct? So let us take few examples of this shift operator. Suppose I am giving A is equal to 40 to B 0, 1, 0, 0. If I shift A by 2 times, what is the result I will be getting? This is nothing but what? A is nothing but what? Operand. How many operands are required to do shift operation? 2 operands. One is A is operand. It is represented in terms of variable. Another operand is represented as a constant. Correct. What is the result of B? What result I am going to get? I am shifting A by 2 times. This is nothing but what? 0, 0, 0, 1. Let us take N is a shift operator. N is a shift operator. Shift operator. If you shift it towards the right shift, this is nothing but what shift it is? The right is shifted by how many times? 2 times. So when I do right shift by 2 times, what is happening? It is division, correct? So 0, 1, 0, 0 is nothing but A is equal to decimal equivalent is 4. What is B is the decimal equivalent is 1, correct? Means the 4 is divided by 2 power n. What is 2 power small n is nothing but 2. So this is nothing but 1. Did you understand? So this is how the shift operator will work. Same case, this is for the right shift operation. This is for right shift. The right shift. Now, can you tell me what is the result of this if I am going to use POTIC B 1101? If I shift this by 1, let us take 1 time. Shift to right this by 1 time. What is the result is? 1101 is nothing but what decimal equivalent is 30. Correct. So this is divided by how many times? 2 power n. 13 divided by 2. Correct. What is 13 divided by 2? 6. It is round up to the 1. Is it? This is round up to the 6. Did you understand? And also we saw one example yesterday. Correct. The example is this is the one. So shift operators are useful because they allow the designer to model the shift operation. Correct. Shift and odd algorithm for multiplication and other useful operations. So let us take one example on this and we'll see. And later you see that how you can do the programming one. Okay. So what operation, what algorithm will do is nothing but shift and odd algorithm. So how to do this shift and odd algorithm? So let us take an example for shift and odd algorithm. How these shift operators will help to do this shift and odd algorithm? Let us take one example to this. Let us multiply 33 into 34. Correct. What is 33 into 34 is 1122. Let us take the calculator. What is 33 into? Just change this into standard. 33 into 44. What is the result is? 33 into 34. The result is 112. The result is 112. Correct. This is a 112. So how to develop a algorithm? Shift and odd algorithm. I said that the shift operator is useful for doing some operations. What operation means? Shift and odd operations. So this 33, how you can write 33 is, this 33 you can write 2 power 5 plus 1 into 34. Correct? So what is 2 power 5? Is nothing but 32. 32 plus 1 is nothing but what? 33. So this equation you can write, how you can write this equation? I can write this is 35 times of 1. 34 plus 1 time into 1. 34. 1 time into 34. So what is 34 in binary? What is 34 in binary? Let us take decimal is 34. What is equivalent of binary is 0, 0, 1, 0, 0, 0, 1, 0. Correct. This is 0, 0, correct. 1, 0, again 0, 0, 1, 0. This is the equivalent of what? 34. No, 33 I am representing as 2 power 5 plus 1. I multiplied with what? 34. So if I am applying the distributive property here, this I can write out 35 into 34 plus 1 time into what? 34. So 34 in binary is nothing but what? 0, 0, 1, 0, again 0, 0, 1, 0. Now how many times I need to shift this? 2 power 5 times. So if I shift this 2 power 5 times, what I will be getting? So I need to shift this by how many times? 5 times. So let me write for understanding. I am going to add in the few more bits. Correct? If I shift this to the left side, 1, 2, 3, 4, 5. How I can write this number is? Now I am shifting this 34 by how many times? 5 times. Now this I can write 0. Now 1, 2, 3, 4, 5 means this one comes in. Shifting left. Again this is what? 0. Again 0. Again 0. 1. 0. 0. Correct. Again remaining bits are what? 0, 0, 0, 0. It will fill what? Remaining bits. If you do left shift, LSB bits are filled with what? Zeros. If you do right shift, MSB bits are filled with the zeros, not ones. Left shift and the right shift. Correct. Now I have shifted this 34 by how many times? 5 times. Now I done with the shift operation using this. Greater than 2, greater than symbol are 2, less than symbol. Now what I need to do? I need to add this 34 how many times? 1 time. What is 34 is? 0, 1, 0, 0, correct. 0, 1, 0, 0. This is nothing but what? 0, 0, 0, 0. So this is nothing but 34 in binary. And this is nothing but what? 34 left shift by 5. Left shift by 5. Then now what I need to do? I need to add this. Add the result. So this is what? 0, 1, 0, 0. This is 0, 1, 1, 0. This is 0, 0, 1, 0. Now you see this is equivalent to the 1, 1, 2, 2. Let us see this. 0, 1, 0, 0, correct? So let me take the calculator. First is what? 0, 1, 0, 0, correct? This is 0, 1, 0, 0. Next is what? 0, 1, 1, 0, 0, double 1, 0. Next is what? 0, 0, 1, 0. After shifting by how many times? 5 times. Then I am adding what? Plus 34. So what is the decimal equivalent of this is? I think I am not properly representing this binary. This is, what is this is 0, 1, 0. So let us remove this 0, 1, 0, 0. Correct. Again next is what? 0. But this one will be shifted here. How I can represent this number in the calculator? Okay, let us do one thing. Let us take the decimal. Okay, 1, 1, 2, 2. Our result. Correct. 1, 1, 2, 2. What is the binary equivalent of this is nothing? 0, 1, 0, 0. 0, 1, 1, 0. 0, 0, 1, 0. So I am getting the same result. Here. You can see this is the result. So the shift operator is to do what operation? This is nothing but what operation I am doing here. This is for the multiplication. Did you understand? Here, this is my multiplier. This is my This is my product.
Hello?
Yeah. Hello.
Once explain 34 left shift by 5, sir. Once again explain 34 left shift by 5. Left shift.
Okay. Okay, let me explain it. So this is the 34. 34 is 0, 0, 1, 0, 0, 0, 1, 0. You know how to represent 34 in binary, right? This number is successfully divided by 2. Take all the remainders from bottom to the top. Integer part. Fractional part, top to the bottom. So this I have only integer part. If I convert this into binary, so 0, 0, 1, 0, 0, 0, 1, 0. This is 34. This 34 I have shifted by how many times I need to shift? I need to shift this by 5 times. Okay, 34 shift by 5 times. So if I write shifting operation of this one will be shifted, right? This one will be shifted by how many times? 5 times. So this I can write, remaining bits are 0, 0. This also I can write like a 34. The meaning of this is nothing but 34, right? If I shift this by left side by 5 times, then where ones comes here? This is a one shift, second shift, third, fourth and fifth. Now this one will be coming here. Correct. Again this 0, this one shift here. Again this 0 shifting here. This 0 is shifted here. This 0 shift here. This one will be shifted here. This 0 will be shifted here. Remaining bits are what? 5 bits are filled with zeros. Okay, for readability purpose, I'm taking all 4 bits. Okay. Now how many times I need to add? 5 shift. Okay, 5 shift. How many times I need to add? One time I should add. What I am adding? 34.
34.
So this is equivalent to what? 1, 1, 2, 2. Did you understand?
Yeah, understood.
Now if I'm asking you 34 into 33, the product will be the same, right? Then how to do that? 34 into 33. So I'm just illustrating here what is the use of the shift operator. Shift operator can be used to develop an algorithm like shift and addition to perform what? Multiplication. Rather than, you know that multiplication can be done also using what? Successive addition. But if I go the successive addition, I will be getting very big circle. So the shift operator helps us to do manipulation easily compared to other technique what we have. Correct. Now let us take next example is 34 into 33. These also results 1, 1, 2, 2. Correct. Now 34 how I can write? 34 I can write 2 power 5 plus 2 into 33. Here 2 power 5 into 33, correct? Plus 2 times of, right? 2 times of what? 33. If I apply the distributive property, this. Now 33 in binary. What is the 33 in binary is? How to write the 33 in binary? To take a decimal is 33. Equivalent of binary is 0, 0, 1, 0, 0, 0, 0, 1. This is binary 0, 0, 1, 0. Again, this is what? 0, 0, 1. This is 2 power 0 is 1. And this is 2 power 16. This is 2 power 2, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5. 2 power 5 is nothing but 32. 32 plus 1 is 33. So this is the equivalent of binary. Correct? Now I need to shift 34 by how much? 5 times. If I shift this, let me write this like this. 0, 0, 0. This is nothing but 0, 0, 1, 0, 0, 0, 0. This is 34, 33 in binary. If I shift this by 5 times, how many times I need to shift here? How many times I need to shift? 5 times. Correct. If I shift this by right time, 5 times to the left, what is this is nothing but 1, 2, 3, 4, 5. This 0, 1 comes here. Correct. This is 0, 0. Again, this is 0, 0, 1. All remaining bits are 1. Rest of the bits will be zeros. Now this is 33. 33 shifted by how many times? Shifted by 5. Now what I need to do? Now I need to add how many times 33? 2 times. First I am going to add 33. This is 1, 0, 0, 0. Again 0, 1, 0, 0. All remaining bits are what? Zeros. This 33. Let me add first one time. This becomes what? 1, 0, 0, 0. Again 0, 0, 1, 0. Correct? You'll be getting carry 1 here. 1 plus 1 is 0, carry is 1. Again this is 0, 0, 1, 0. So this is first add. Correct? And again, this result I need to add. How many times I need to add? 2 times. Again, 2 times means what? 1, 0, 0, 0. Again, 0, 1, 0, 0. Again, this is 0, 0, 0, 0. Now what this? 0, 1. I'll be getting carry is 1 here. Again, this is what? 0, 0. Again, 0, 1, 1, 0. Again, 0, 0, 1, 0. So this is equivalent to what? 1, 1, 2, 2. Correct? So 1, 1, 2 in binary equivalent is what? So 1, 1, 2, 2 is a binary equivalent is 0, 1, 0, 1, 0, 0, 0, 1, 1, 0, 0, 0, 1, 0. I'm getting the same result. 0, 1, 0, 0, 0, 1, 1, 0, 0, 0, 1, 0. So this shift operator help us to design a shift and add algorithm for multiplication.
So the process was not understood, sir. Please explain once.
I'm clearly explaining which point you are not understanding. I was
Here,
giving two
33
examples.
shifted by 5.
So if I shift
How
this
it is shifted?
see how many times I need to shift. 5 times I need to shift. Correct. Left shift I'm doing. So this is a 30,
Yes, sir.
33, 0, 0, 1, 0, 0, 0, 0, 1. If I shift this by left side means how many times I need to shift? 1, 2, 3, 4, 5. Means this one will be shifted here. How many times? 5 left shift I need to do. This 0 will be shifted here. This 0 will be shifted here. Again, this 0 is shifted here. This 0 is shifted here. And this 1 will be shifted here. And remaining bits of this left shift operation will fills with what? LSB bits fills with the 0, 0, 0, 0. Now, how many times I need to add is 2 times I need to add. After shifting this, 33 shifted by 5 times, I am adding a 33 to this. And then this result again I am adding the second addition. 2 times I need to add the 33. So that gives me the result as 1, 1, 2, 2.
Thank you, sir. Okay. Understood.
Is it clear this? Huh? Now, and then I'm asking to write a program, right? To write a program of walking ones and walking zeros, right? Are we done with walking ones and walking zeros using shift operators? Using shift operator. How to do walking ones and walking zeros of the shift operator? So if I declare integer A comma B, correct? A comma B. Let us write initial begin. I'm assigning A is integer. If I write one tick B0 or one tick B1, what it is going to assign here? A. I'm using one tick B1, assigning A. Then integer means how many bits? 30 digits. So in A, what you have like this 0, 0, 0, 0, correct? Up to so on 0, 0, 0, 0, like up to so on 0, 0, 0, 1, assigning to the 1. Now I need to shift this by how many times? 1 time. So I want to do walking once first. Left side walking. So what operator I should use? B is equal to, correct. B is equal to what? A. Left shift operation by how many times? 1 time. Now what is my B result is? What is the B result will be? 0, 0, 0, 0, right? 0, 0, 0, 0. Again, this 1 will be shifted by the left side by ones. Now I want to write a program to like walking ones and walking zeros using the shift operator. So how to write a program to this? How to write a program to this? Let us write integer. Let us define the module. Let us take module TB, correct? And how many variables is required? 2 variables. Let us take integer A comma B, declare the variables A comma B with the integer data type. Now I am going to assign. In the initial begin, I am going to assign A is equal to what? 1 tick B1, correct? Now I am using the shift operator. B is shifted by how many times? Left shifted by 1 times. Now let us print the A and B value. How to print the A and B value? Now A is equal to percentage B, and then in the next line I am going to print B is equal to percentage B. Then what argument I need to pass? A comma B. Then I am going to finish. Then I am going to end this initial begin. Then end the module. Now A is nothing but what? LSB bit is 1 and all remaining rest of the bits will be what? Zeros. Now I am doing what shift operation? Left shift operation. So B is nothing but shifted by how much? Shifting operation left means what? Divided or multiplied? Multiplication. Correct? So if A is equal to 1, B is nothing but 1. And shifting by 1 times, what is B value is? 2. Correct? Now this is the result. A is equal to LSB bit is 1 and all remaining are what? Zeros. I am shifted this by how much? 1 time. If A is 1, B is nothing but 2. It is a 2 power multiplication. Correct? Now I want to write a program like walking ones and walking zeros. Walking of ones and walking of zeros. Can you write a program for walking of ones? Write a program of walking of the ones. How to write a program to this? How to write a program to this? I want to shift this 1 by left side by 1. In the next term, I want to shift this 1 year. Again next 1 year. 1, 2, again next is 4, next is 8, 16, 32, so on. How to do this? I want to put this into what? Loop. Any loop I need to put. So let us use the for loop. For, I am going to declare, I am using the variable in the for loop so that I am going to declare I as an integer. Okay. Now I am going to start. Initially I am going to start with what? I is equal to 0. Then what is the condition? I is less than or equal to 1. I need to put this through the loop. When I is equal to 0, 1 shift. When I is equal to 2, 2 shift. I is equal to 3, 4, 5, so on. So what is the condition I need to do? How many times I need to shift? 32. Then I is incremented what? How many times I need to increment? I is incremented by 1. I is equal to I plus 1. If this is my for loop, if we have the multiple statements, what is the begin? Correct? Begin and end. Now I am shifting this. Then let me print only the B value. Only B value. Okay. Then I am going to end. In the for loop. Once this is done, I am going to finish this. Then I am printing the walking of ones and walking of zeros. So each iteration I am printing the B value. When I is equal to 0, I is equal to 1, 2, so on. You can see it is not shifting, right? For all the values, I is nothing but 1. So all 32 iterations, now loop is executing from 0 to 32. But in each loop it is not shifted. It is printing same. What I need to do? Press this. I is equal to. This is what I am incrementing. I is equal to I plus 1. First I is equal to 0, it is coming to this loop. Okay. Initially, what is A value is nothing but. LSB is 1, remaining bits are what? 0, 0, 0. Now I am shifting A by what? 1 time. That will be assigning to the B. Okay. After assigning to B, what I am doing? I am printing the value of B.
You give I greater than or equal to 5, P equal to A left shift to I is the I you get value, sir.
I is equal to 0.
I greater
Then I
than or
is
equal
less
to
than
5.
Why I need to do 5? I want to do walking of one side. First
Yeah,
this
5
bit is
second.
1, then it should have been here, then it should shift here. In next iteration it should shift like this. Ones are like a walking.
In below condition, to B equal to A left shift I, sir. Not 1.
B is equal to
A left shift
Or if I am going to I do initially
A
A
left
value is
shift.
equal to 1.
I sir,
Again, I can do like this.
But then you have
P
to
equal
display
to A left shift I sir.
Is equal to here this is B. Let us print B. What I need to do, I need to shift this, right? Since I'm giving 1, it is shifted by only 1 times for all the iteration. Here what I need to do, I need to replace 1 by I. Did you understand? Now let us run this program. Now you can see ones are walking. Are you understanding this? See, this is one of the interview question. That's why I'm telling you this point. Asking to write a program using shift operator, write a program for walking up ones and walking up zeros. Now I'm making the walking up ones here. Did you understand this? Now how to make walking up 0? I want to make walking up 0. Walking up 0 I want to make. Walking up 0 means all these bits I need to make 0. And this one is converting into, this 0 is converting into 1s. And this 1 is converting into zeros. What I want to do? You just do the negation of this, right? Complement of this. To negation of this, what operator I can use? Twiddle symbol, twiddle, bitwise operator I am talking about. Correct. So this twiddle operator will give the multiple bit output, right? The logical operator will give only the single value output. This will do multiple bit. Right? Now I am complementing the zeros to ones and ones to zeros. Now it is printing this one. Now I am making a what? Walking up 0 to the left. Now you can do same thing for what? Right shift operations. Correct? In case right shift, how it will go? The right shift, what I need to do? Let us take this is a program of what? Walking up zeros. Now I want to do right shift. What I need to do? Now what is the A value I need to assign? If I am doing right shift to this, what happens? Initially A is nothing but what? LSB is 1, remaining bits are zeros. If you shift by right, all the iteration I will be getting zeros only, right? I will be getting zeros only. You can see, initially B is nothing but this is 1. Okay. Remaining, if I am shifting towards right side, so this 1 will vanish and the rest of this bits will be filling with what? Ones, zeros. I will be getting zeros only. Then how to do walking off ones to the right side? I should make this bit is what? 1. This bit is 1. Correct? Then I need to shift to the right. Did you understand? You think of this program. So let me give the assignment. The assignment is write a program. Write a program of walking up ones, walking up zeros and ones using right shift operator. Right shift operator. You take this as an assignment. Take this as an assignment. So this is regarding about what operator we talk about, shift operator. And then you can also take an assignment and work with this operator. What operator is? Assignment. assignment is work with this operator. Work with what operator? 3 greater than symbols and 3 less than symbol. I am leaving this as an assignment. Okay. We understood what is a 2 greater than symbol, what is a 2 less than symbol. So what is the use of what it will serve in the very large 3 greater than symbol and 3 less than symbol. You find the information regarding this, work on this operator. Now let us go to the next operator is concatenation operator. Concatenation operator. So what is the use of this concatenation operator? Verilog is nothing but it is used to provide the mechanism to append the multiple operands. If I want to append the multiple operands, I can use what operator? Concatenation operator. The concatenation operator is denoted by what? Power brackets. Power brackets. The operands are separated by what? Comma. Operands are separated by comma. So this concatenation operator provides a mechanism to append the multiple operands. Okay. So the operand must be what? It should be sized. It may be 1 bit, it may be 2 bit, it may be 3 bit. It should be what? Sized. Sized number means what? What is meant by size and number is? Size format, size thicker. Base format followed by the what? Number. So when you are working with the concatenation operator, operands must be what it should be. It should be size. So unsized operands are not allowed because the size of the each operand must be known for computation of what? Computation of the size of the result. You know, numbers are representing using what? Size, correct? Ticker. Format, tick what? Sorry, format, then number. This is nothing but size and number. Size and number representation, correct? What is unsized number representation? Only ticker, format, then number. So what is the problem with the unsized when you are working with the concatenation operator is, your operand must be always a size and number. You should use this number when you are working with concatenation operator. If you are using unsized operands, not allowed because the size of the each operand must be known for computation of the what? Size of the final result. If you know that what is the size of the bits number, you can able to find out what is the final size after concatenation. If you are using unsized number, it is not allowed because the size will be of the each operand must be known for computation of the size of the operand. Did you understand this? When you are working with the concatenation operator, you should use what number? Size and number. So concatenation are expressed as operands with what? Operands with what? If I am writing A comma B are the operands. Operands with what? Braces. I am using the braces. Operand with the braces with what? Comma separated by the operand. So here A and B are the operands. If I am talking about A is operand and B is operand, so this is represented with the braces separated by what? Comma. So you are using this concatenation operator many times in your test benches, right? So when you are generating the random values assigning to the A and B variables, you are using like this dollar symbol, correct? Random. This random dollar symbol random will generate the random 32-bit value. So that will be assigning to what? B and A. LSB will be assigning to B. Remaining LSB bits are assigning to the A. Correct? So this is how you can concatenate a mechanism to append the multiple operands. So these operands can be what? Operands, whatever the operands A and B are using, this may be what? Scalar net means what? Wide data type. It may be what? Scalar register, 1-bit register, or it may be what? Vector nets or vector register, or it may be what? Bit select, only 1-bit select, or it may be what? Part select. What is meant by part select means? Suppose your register is 7 down to 0, I want to select 3 down to 0, now that becomes a part select. So operand should be what? Part select, or it should be what? sized constant. Sized constant. So this is how the operands can be used to do the concatenation operation. Now let us take few examples on this concatenation operation. Here concatenation operation A is how many bit? 1 bit. It is sized number or unsized number? Sized number. B is nothing but what? 2 bit. Sized number or unsized number? You know, I know what is the size of this. What is C is nothing but 2 bit size number. What is D is nothing but 3 bit size number. Now you can say I am concatenating. What is the operator used to concatenating? If I am concatenating can be done using braces or flower brackets. Here A, B, C, D are the operands here. If I am concatenating B, C, what is the result I will be getting? What is B is 2 tick B 0 0. What is C is 2 tick B 1 0. How this will be concatenated? B is nothing but 0 0. C is nothing but what? 1 0. So what is the size? This is nothing but 4 tick B. This is how it is concatenated here. You can understand? Now you can see this example. How many operands I am concatenated here? A is one operand separated by comma. B is another operand separated by comma. C is another operand and then separated by comma. D is another operand separated by what? Comma. What is the last I am giving? Operand as a size number with a constant. Size constant this is. Correct? How many bit I am giving? 3 tick B 0 0 1. So if I concatenating this, what result I am going to get? So first it should start from here to here, right? A to B. So this is 1 0 0. What is D is nothing but 0 1 1. Correct? For your understanding, I am writing like comma here. Okay. Again, C is nothing but what? 1 0. Correct? What is B is nothing but 0 0. B is nothing but 0 0. Correct? What is A is nothing but 1. Now this is A, this is B, this is A, C, this is D, and this is nothing but constant number. What is constant number is 3 tick B 0 0 1. Now what is size of this is Y is now 1 2 3 4 5 6 7 8 9 10 11. It is 11 tick what it is binary. So when you are concatenating, keep in mind that the operand should be what? Size number. If I am using unsized number, it is not possible to compute what is the size of the Y. Correct? So that these operands here ABC may be the one. Scalar or vector, net or a register. It may be what? Bit selection, part selection or a sized constant. Sized constant number. Did you understand? Now can you see the next example what we are doing here? What is this example is? A comma B of 0 comma C of 1. So we are doing what? Here this is nothing but bit selection. I am not doing part selection here, right? Bit selection I am doing. What bit selection? A is 1 now, correct? B of 0 means what? This 0 0. B of 0 means what? This is B of 0. This is what? B of 1. This is your B of 0. Correct? This is your B of 1. Did you understand? So what is B of 0? 0 is nothing but 0. Now this select the 0. What is C of 1 means? This is C of 0. Correct? This is C of 1. This becomes 1. Correct? Now this is a result 1 0 1. How many bits it is? This is a 1 bit. This is a 1 bit. This is a 1 bit. It is a 3 tick B 0 B 1 0 1. Did you understand this? How to work with the concatenation operation? Then can you write a program to this to check this? Can you write a program? Okay, how to write a program to this concatenation operation? First we need to declare, right? Declare the variables. So what is a reg A is? Reg A is a scalar. Correct? Shall I initialize here itself one tick B 1? Is it fine? No problem. What is next is reg. What is B size is? 1 tick 0. 1 colon 0. This is B is equal to what? 2 tick B 0 0. B value is 0 0, right? What is C value is? Range 1 down to 0. C is equal to 1. 2 tick B 1 0. Correct? Then what is next is range D. D is how many bits? 3 bits. 2 down to 0. D is equal to 1. 3 tick B 1 0 0. Correct? 1 0 0. Now I need to do the concatenation. How to do the concatenation? Let us work one by one. What is the first concatenation? So I am going to declare like integer y. I want to assign the output, right? Or you can declare this reg is equal to 31 down to 0. Now this y will is a unsigned, signed integer now. If you declare this as what? Reg 31 down to 0. Now this becomes what? Unsigned. Reg is unsigned quantity. Integer is what? Signed quantity. Are you understanding? Now I want to concatenation. What is the concatenation is? We are doing is y is equal to, correct? Y is equal to what we are doing? Concatenation, what process we are using? Proper brackets. Right? Now I am concatenating what? A comma B. Then colon. Now I need to print the output y. Let us print the output y. Capital Y. And then what argument I need to pass? Capital Y. So what is the output I am going to get for this? What is the concatenation I am doing? So this I need to close. So it should take how many bits? Here reg I am declaring this as output 30 down to 0 means it is reg is 32 bit. Register I am declaring. Now since after doing this output, after concatenating this I need to assign the variable, right? That variable I am declaring here. That variable I am declaring with what data type it is? Reg data type. Did you understand? Now I am doing the concatenation. After doing the concatenation, I am assigning to what? Y. Then I am printing the y value. Are you understand this? Now, if I do 0p, what it is going to print? So remove the zeros or remove the spaces, correct? Now what is the concatenation of this two? How many bits of y? A is 1 bit, B is nothing but what? 2 bit. How this will be concatenated? B is nothing but 0 0, A is nothing but 1. So result will be what? 3 tick B 1 0 0. 3 tick B 1 0 0. You can see it is 0 0 1. Did you understand? If I remove this 0, 0 it will print because since I am declaring this as a register, right? It will print what? All 32 bits. I am adding the 0 here to print only what? The number. It will remove all the zeros. So that what is my y size is it is? 3 bit. Correct? If I am going to concatenating A comma B comma C, what will happen? Which batch is digital verification? No, September batch. Theory is going on. Afternoon. Now I'm concatenating A, B, C. What is the result I will be getting? How many bits? C is 1, 0, 1. B is 0, 0. A is 1. Correct. Now total how many bits it is? 5 bits. Now these are 5 bits. Correct. If I'm doing comma D. So D is 3, 2, 2. This is 4 plus 3 is 7. This is 1 means total 8 bit. Now total 8 bit. This is 4 bits. This is another 4 bits. I'm concatenating what I'm concatenating? A, B, C, D. Now next is, if I'm going to give the constant lengths, we take B 1, 0, 1. 1, 0, 1. So what it is going to concatenate? How many bits it is? So 8 plus 3 is nothing but 11. Now it is total 11 bits. Correct? This is an example I am working on. These are the examples. So this is how you can concatenate. Are you understanding how to use the concatenation operator? So most of the time in Verilog programming, we used to work with the concatenation operator. Okay. So what are the rules you need to follow when you are working with the concatenation operator? Can you tell me what is the rule? What is the rule? So operand should be what? Should be size and number. It should be scalar net or vector net. Correct? Scalar register or vector register. It should be size and constant. Correct? So these are the rules you should follow. These are the rules. Part selection or bit selection. Now in this program, how to do part selection? Suppose if I'm using B of 0, let us take C of 1 and D of 1 down to 0. Now you tell me what is the size is. This is 3, 2, 3 plus 2 is 5, this is 6, 7, this A is 1B. Total how many bits? 8 bits. Now this will be concatenating from this data. This is 1, 0, 1. E 1 down to 0 means what it is going to select? 0, 0. Correct? Again, C of 1 means what? 1. B of 0 means what? 0. And then A is nothing but 1. Now total how many bits? Output size is what? 8 bit. As you can see, this is 8 bit. This is a 4 bit. And this is the another 4 bits. So this is how you can work with what? Concatenation operation. So this is another operator is concatenation operator. Concatenation operator. Now let us go with the next operator. You have any questions on this concatenation operator? Now next operator is nothing but replication operator. Replication operator. What is this replication operator? Name implies replication means what? What is the meaning of replication means what? You are replicating same to 2 times, same to 3 times, same to 4 times, 5 times, doubling. Right? Replication means doubling. So what is replication operator is? So repetitive concatenation of the same number can be expressed by using what? Replication constant. Understand this definition, first one. The repetitive concatenation of the same number, the repetitive representation of the same number can be expressed using what? Using concatenation replication constant. So a replication constant specifies how many times to replicate the number inside the brackets. Number inside the brackets. Let us take an example to this. Now A is declaring as a reg 1 bit. A is the scalar, correct? What is B and C is nothing but vector with the 2 bits. D is nothing but vector with the 3 bits. And we are initializing the A value. A is how many bit? 1 bit. It is same as in previous example. B is nothing but what? 0, 0. C is nothing but what? 1, 0. D is nothing but what? 1, 1, 0, 1, 1, 0. Now I want to replicate A by 4 times. How to replicate this? What is meant by replication operator means? It is going to what? Repeating. It is a repetitive operation of concatenation can be done using the replication constant. I want to repeat A by 4 times. So this is your replication constant. Replication constant. Replication constant. So here I am using y is equal to 1. So this is the operator we are using, replication operator. Replication operator. I am using this 4 times of A. 4 times of A. So A is initializing with the 1 tick B1. How this? What is the result of this? Is a replication operator I am doing. How many times it is replicating this? This is nothing but replication constant. This is a replication constant. This is replicated how many times? 4 times. What is the size of this after replicating? 4 tick B 1 1 1 1. You do understand? So this is a replication operator. You can see the first example. We are using y is equal to what? 4 times of what? A. This result is what? 4 tick B 1 1 1 1. Let us see that how to replicate this. What is operator I can use? Replication operator. How to replicating the A? Using replication constant 4. How many? What I need to replicate is A. Correct? This is my replication constant. Now what is the value of y should be? How many times A is replicated here? 4 times. Now result of y should be what? How many bits? 4 bits. 1 1 1 1. Did you understand? If I am giving 3, what happens here? It is replicating by how many times? 3 times. Y is how many bits now? 3 bits. Are you understand what is meant by replication operator? So replication operator is nothing but repetitive concatenation of the same number can be expressed using the replication constant. Replication constant specify how many times to replicate the number inside the brackets. So this is the first example. Now you can tell me what is second example is. 4 A is replicated how many times? 4 times. B is replicated how many times? 2 times. Then what is the size of the y should be? The size of the A is one bit, 1 ticker. Size is 1. Now if I replicate this, what is size it should be? 4. Now B is size is originally it is 2. Now I am replicating this. How many times I am replicating? 2 times I am replicating. What is the size of this is nothing but 4. What is it? Then final size of the y it should be 8. So how it will be replicating? B is replicating 2 times means what? 0 0 0 0. First it is replicating this 0 0 0 0. Then it is replicating of what? A. How many times A is replicated? A is the 1 bit. I am replicating this 4 times. This becomes what? 1 1 1 1. Total what is the size of this is nothing but 8. Did you understand this replication operator? Now let us work with this. So how to do next second example? So now we are replicating with the A. Now what is second example is? 2 times of A. This will be separated by what? Comma. Correct? Then this is replicated how many times? 4 times. Sir. This is 4 times. Comma. How many times it is replicated? 2 times of what? B. Correct? Now what is the y value it should be? 8. 8 bits, what is the result will be? 0, 0, 0, 0, 4 zeros and 4 ones. 4 zeros and 4 ones. It is some syntax error here. The syntax error, it is showing that the internal closing of the repetitive concatenation. So here I am using two repetitive concatenation. So what I want to do, I want to use the closing of this first concatenation and closing of the second concatenation. So this is what error I am getting. Now what is the y value should be? Y value is 8 bit, 4 zeros and 4 ones. You to understand this? The second example. What is third example is? What is the next example is? The next example is, so A is replicated how many times? 4 times. B is replicated how many times? 2 times. Then I am concatenating with what? C. But C is not replicated, only 1. It is by default, its replication constant will be what? Only 1. Correct. Now what is the result of this is? 4, 4, then 2. 4, 4, 2 means what? Total it will be 10. But here it is printing wrong here. Okay, this should be bits of how many bits? 10 bits. So now let me work with this. I am going to concatenating this one. Concatenating with the C value. Now what is the size of the Y? It should be 10 bits. You can see 1, 0, 1 is C. 0, 0, 0, 0 is nothing but B. B is replicated 2 times and A is replicated 4 times. Total size it should be 10. Did you understand this replication operator? So repetitive concatenation can be done using the replication const. This is a replication operator. So this is regarding about replication operator. Now let us go with the last operator in Verilog. Is nothing but a conditional operator. So what is this conditional operator? Is a conditional operator is what operator? It is binary operator, unary operator, or is it a ternary operator? It is a ternary operator. So why it is a ternary operator? Since it requires how many operands? It requires 3 operands. The conditional operator can be denoted by, let me write it here, the conditional operator denoted by what symbol? Denoted by the symbol of what? Question mark with what? Colon. Question mark with colon. This is a ternary operator. Ternary operator. Can you write a syntax to this ternary operator? How to write a syntax to the ternary operator? Can you write a syntax of the ternary operator? First is, this is the condition you are writing. Condition. Correct. Followed by what? Question mark. And this is nothing but statement. What statement it is? True expression statement. Colon. Next what? False expression. Next is false expression. Suppose let us take a 2 cross 1 multiplexer. 2 cross 1 multiplexer. How many inputs will be there? 2 inputs. I0 and I1. How many select lines will be there? 1 select line, 1 out. Correct. So your conditional operator exactly replication of your multiplexer, 2 cross 1 multiplexer. Here I am putting the condition. Correct. Here I am putting the condition. If condition is 0, what it is going to connecting here? It is selecting as a data selector. I0 will be connecting me to the Y. If my condition is 1, I1 will be selected. Right, I1 will be selected. This operation of the multiplexer. Here, when this is true, when this is equal to 1, so this will be selected. True expression will be evaluated. When condition is 0, false expressions will be evaluated. Did you understand? Let us write the expression. Totally how many operands I have? 3 operands. Condition, true expression, and then false expression. So this we call it as a ternary operator. So now let us take few examples on the ternary operator. So this ternary operator is denoted by what? question mark and colon. So the condition, what is the usage of this is nothing but you are writing conditional expression, then you are writing what? True expression, then you are writing the false expression. So if I write for the 2x1 multiplexer, how to write the 2x1 multiplexer using the conditional operator? How to write? You are writing the condition here. This is your select line S0. If S0 is true, what it has to select? I1, correct? If S0 is equal to 0, what it has to select? I0, correct? So this I am going to assign to the y. If S0 is equal to 1, it is selecting what? I1. If S0 is equal to 0, it is selecting what? False. I0 will be selecting at the y. So I can very easily write the 2x1 multiplexer using what? Conditional operator. Did you understand this conditional operator? So this is what this is the usage of the conditional operator. Conditional expressions or control expressions, question mark followed by what? True expression, colon, then what? False expression. So this is like an if-else statement. Conditional operation works like an if-else statement. The conditional expression is a first evaluated. In this three expression, which expression first it will be evaluated? Conditional expression. Based upon this conditional expression, this will be selecting the true expressions or false expression. So if the result is true, this conditional expression result is true, means 1, what it is going to select? Then the true expressions will be evaluated. If the result is false, means logic 0, this conditional expression is logic 0, then what it is going to evaluate? It is going to evaluating the false expression. You can understand. So let me write here itself. I am writing the 2x1 multiplex. Okay. So this is my conditional expression. If my select line is 1, means this is what? Logic 1. When logic 1, what it has to evaluate? True expression. True expression I am going to write I1. It is selecting the I1. If my conditional expression is 0, what it is going to evaluate? I0. Did you understand? So if the result is ambiguous, means unknown, then both the true expression and false expressions are evaluated and the results are compared. And the results are compared by what? Bit by bit and returns for the each bit position in the X. If the bits are different, the value of the bits, if they are the same. Means, if my result is ambiguous, means my conditional expression is what? Unknown. In such a case, how this conditional operator will be evaluated? Here it is logic 1, which one it will be evaluated? True expression. If it is 0, what it is going to evaluate? False expression. What happened? There is a X here, ambiguous, unknown. What it is going to evaluate? Now in this case, you understand this statement. If the result is X, then both the true expression and false expressions are what? Evaluated. Both the true and false will be evaluated and their results are what? Then the results are compared. Correct? Bit by bit to return for the each bit position on X. If the bits are different and the value of the bits if they are the same. Means when this is the conditional expression is ambiguous, then it is start comparing what? Bit by bit. Both the true is also evaluated, false also evaluated, then it is comparing what? Bit by bit comparison. When my conditional expression is what? When this will get this one? When you are getting your conditional expression is what? Unknown, ambiguous. Did you understand? So the action of this conditional operator is similar to what? Multiplexer, what I wrote here. If you look at this action of this conditional operator is similar to the what? Multiplexer operation. So you can see here, alternative to this if-else expression is nothing but a conditional operator. If the condition is to what body it is executing. If If you write the if statement, how you can write the if statement? If this is 1, so now it is executing this statement, right? If statement. Else, what statement it is executing? Else statement. Now this conditional operator is similar to this. I can use conditional operator instead of what? Alternative to what? If else statement. If my conditional expression is true, what it is going to express? True expression. If it is false, false expression. That is similar to this if else statement. Did I say like that? Conditional operator is similar to what? If else statement. I can say alternative to the what? If else condition. So this is also like equivalent to what? Multiplexer. If my control expression is 1, this true expression will be evaluated. If my control expression is 0, correct? False will be evaluated. If my control expression is what? Unknown, both will be evaluated and then comparing what? Bit by bit comparison. Did you understand this conditional operator? So this is the conditional operators. So conditional operators are very useful to modeling the multiplexers. You can model the 4x1 multiplexer. You can model the what? 8x1 multiplexer. So on. So this is regarding about multiplexer. Now let us take few examples on the conditional operator. So conditional operators are frequently used in data flow modeling to model the conditional assignments. What is mean by conditional assignments? The multiplexer operation is what? Conditional assignment, right? Conditional expression is 1, it is selecting I1. If it is 0, it is selecting the I number. So to model this in the data flow modeling, so we'll be using what? Conditional operator part, modeling the conditional assignment. These conditional expressions act like a what? Switching control. Another way this, you can tell that this conditional expressions, it is acting like a switching control. Your multiplexer is a switching control. Correct? Based upon control select line, it is going to select the I0 and I1. That is nothing but controlling of the switches, which data should be selecting to the output. So that can be done using what? Switching operation. Okay. So to model the functionality of the tri-state buffer. What is a tri-state buffer? So this is a buffer, right? Where output follows the input is nothing but what? Buffer. So we are adding one more input to this. That is nothing but enable. This is a enable. So when this is active enable or active low enable? This is active enable. If enable is equal to 1 only, it is acting as what? Buffer. Means you have a connection, switching connection from Y to the A. What is active low enable means? There is a bubble here, correct? So active low enable, I am going to write A complement. So this is A and B. This is A, input is A and output is Y. So when this is equal to 0, then it is acting as what? Buffer. Output follows the input. Output is a mirror of input, we call it as a buffer. Correct? I can easily model this. I can easily model this tri-state buffer. Why we call this a tri-state buffer? How many states will be there in the tri-state buffer? 3 states. What are the 3 states? One is 0 state, 1 state, then high impedance state. Means floating state or open state. Z is nothing but what? High impedance state. Now how to model this tri-state buffer using a conditional operator? You can write what? Dry mode. Dry mode is nothing but here enable. If enable is equal to 1, I am taking what? Address output. If enable is equal to 0, what output I am assigning the address underscore bus is nothing but I am assigning the high impedance. Means, so here it is 36 tick B of Z. Means Z means what? Floating. High impedance. When it is high impedance state. So if I write the tri-state buffer, okay, you can understand this. This is my tri-state buffer. This is enable. This is A and Y. If you write the truth table of this, enable is the one input, A is the one input, and Y is the output. So when enable is 0, irrespective of my input, what is my output is? Z, floating state. This is active enable. When this is working as a buffer, enable is 1. If A is 0, Y is equal to 0. If A is 1, enable is 1, Y is 1. How to write the active low enable then? This is active low enable, E bar, A, Y. When enable is 1, irrespective of this, what is this is? High impedance state. When enable is 0, A is 0, Y is 0. Enable is 0, A is 1, Y is 1. So this will be called it as a tri-state buffer. How many states are there? 3 states. High impedance state, 0 state and 1 state. So this is tri-state buffer. Now this I am modeling using what? Conditional operator. Correct. So this is nothing but enable. If enable is equal to 1, what it is going to evaluate? This true expression. What is true expression I am doing is nothing but address underscore output. Whatever the output is there, I am assigning to this address underscore bus. If enable is equal to 0, what happens here? It is evaluating the false expression. What is my false expression? I am writing the expression is high impedance state. The size I am taking is 36 dB. That means high impedance state is assigning to what? Address underscore bus. Now this I am modeling with tri-state buffer. Enable is 1 means output follows the input. Enable is 0 means high impedance state. Did you understand this conditional operator? Now you can see you are modeling a 2x1 multiplexer. How to model the 2x1 multiplexer using conditional operator? This is your control line or select line. Let us take control line here is nothing but select line. S naught. If S naught is equal to true, then this is logical 1. Correct? When this is control is nothing but S naught, I am taking, or you can take control itself. If control is equal to 1 means what? It is logical 1. When this is logical 1, which expression it will be evaluated? I input 1. When it is logical is 0, which expression it will be evaluated? False expression. So when it is 1, it is selecting it. Output as IN1. When it is control is 1. When control is 0, it is selecting the input IN0. So this is how you can model the functionality of what? 2x1 multiplexer, tri-state buffer. All multiplexer, higher order multiplexer can be modeled using what conditional, what operator? Using conditional operator. Did you understand? So this is list of the operators we widely will be using in the most of the time in behavioral model or in the data flow model. All these operators. Did you understand? Now we'll see what are the precedents. What are the precedents of the operators? So what is the highest precedence? What are the operator symbols will be having the highest precedence? Highest precedent. First highest precedence we are giving into what? Parenthesis. Open and close parenthesis. That should be having the highest parenthesis. Usually when you are writing a program, we used to recommending you to do the parenthesis. Any expression you are writing, we'll ask you to put into the what? Parenthesis. To avoid the operator precedence. So we'll talk about that. Okay. So this is another example. You can go through this. Okay. So this is, if A is equal to 3, when this is true only, this will be evaluated. If this is false, this will be evaluated. So this is an example of modeling a 4x1 multiplexer. Okay, you can go through this. So this conditional operator, I can say alternative to this example for alternative to the nested if state. Correct? Previous one, it is working as one if else state. You can also nested the conditional operator. So this is the example. 4x1 multiplexer is the example for the nested if state. Okay, you can go through this. Now let us see what is the order of precedence. What are the symbols will be having higher order precedence? What are the symbols will be having a lower order precedence? See, if no parentheses are used to separate the parts of the expression, Verilog enforces the following precedence. If you are not using the what? Parentheses. So Verilog by default it will enforce us to do the precedence according to this. So unitary operator like plus and minus, negation operator and build symbol, these operators will be having what? Higher order precedence. Unitary operator. And next to this unitary operator is nothing but multiplication, division and modulus having a higher order precedence. So this multiplication, division and modulus will take how many operands? 2 operands. Unitary operator will take how many operands? 1 operand. So whatever the 1 operand symbols you are using, these operators will be having higher order of precedence. Okay, multiplication, division, modulus will be having next to this unary operator. Again, subtract, addition, subtraction, shift operator is comes to next to your multiplication, division and modulus. Then relational and equality operator. Then comes what? Reduction and logical operator. Your conditional operator will be having what? Lower order of precedence. Lower order of precedence. So highest order of precedence is given to what? If you are writing an expression with multiplication with a unary operator, which operator first it will be evaluated? Unary operator, followed by what? Next, binary operator. If you are not putting into the parenthesis. If you put the parenthesis, according to the parenthesis,